All right, so this first question, are these three ratios equivalent? The answer is false. The reason being 9/16 cannot be simplified to 3/4. So if I divide these terms both by 3, I can divide 9 by 3. I cannot divide 16 by 3. Therefore, this cannot be simplified to equal 3/4. 15/20, if you divide them both by 5, it can be simplified to get to 3/4. So therefore, 3 to 4 and 15 to 20 are equivalent. If I changed 3 to 4 to 6 to 8, so I multiplied both terms by 2, then I would be completing the statement to make it true, and 6 to 8 is equivalent to the other ratios. On the next one, this question is part to whole. Sam's hockey team had 6 wins and 5 losses in their season. This is a part to part relationship. The reason being is you're looking at wins and losses. Our whole would be 11 games played. So to be a part to whole ratio, we would have to say, therefore, Sam's hockey team had 6 wins to 11 games. 6 to 11 is part to whole. Next up, 6 to 4 is the simplest form of 12 to 8. 6 to 4 is the simplified form of 12 to 8. It's not the simplest form, though. Notice that 2 is a factor of both of these numbers. These can both be reduced further. So 6 to 4, if you divide both terms by 2, can be simplified to 3 to 2. Therefore, 3 to 2 is the simplest form. Next page. Reduce the following ratio to the simplest form. So 72 to 81. What you want to do here is find their greatest common factor. If you know the greatest common factor between 72 and 81, when you simplify them, that will be simplest form. So I know that 9 goes into 72, and I know that 9 also goes into 81. So if I divide 72 by 9, I get 8, and if I divide 81 by 9, I get 9. Therefore, 8 to 9 is simplest form. The following, convert the following two to unit rates. We talked about unit rates being something compared to a unit of 1. For this one, I want it down to kilometers per hour. So I'm going to say 45 km per 9 hours. To simplify this to 1, I'm going to divide it by 9. Now I'm at per 1 hour. Whatever I do to the second term, I need to do to the first term. So I'm dividing the first term by 9 as well. 45 divided by 9 is 5. Therefore, the unit rate is 5 kilometers per 1 hour. Next up here, we have $65 per 120 minutes. 120 minutes, we would not usually express someone's salary per minute unless you're someone like LeBron James and you're making a ton of money per minute. So for this one, I know that 1 hour is 60 minutes, therefore 120 minutes would be 2 hours. So I can also express this rate as $65 per 2 hours. I know to get this to a unit of 1, I divide it by 2. I divide this by 2 as well. Now right away you might be thinking, hey, Mr. Meakin, 2 isn't a factor of 65. Remember, the nice thing about ratios and rates is that you can have decimals incorporated. So I know that if I have 32 and a half, that's half of 65. So 32.50, so $32.50 per 1 hour. Next page. Where are ratios used in real life? Answer the question and provide an example. We did a couple of these examples in class. One easy one is we talked about Sterling Hall, and so you could say a school may have a student to teacher ratio of 8 to 1. So 8 students for every teacher. Obviously, the smaller the ratio of students to teachers, the more time that students would have one-on-one with teachers in that school. Another example is we could talk about a ratio or a rate, sorry. A rate could be Steph Curry shoots 32 points per game. Pretty great player. So we would say 32 points per game. There's an example of a ratio. All right, this one. Answer the following question by completing a table and a graph to justify your answer. Mr. Meekin needs to steal this handy-dandy notebook here to use as a ruler. We need straight lines. So first thing we're going to do is we're going to make a table. So we can just make a T-table or a T-chart. One line down the middle. One line across the top. My chart's going to have two columns. The first column is going to be distance, and the second column is going to be time. So I have 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. You can even go to 6 if you want, but 5 is fine. We want to know how long the drive would take if it how far the cottage would be if the drive lasted 5 hours. So if he's averaging 85 kilometers an hour, after 1 hour, he's gone 85 kilometers. And this is distance in kilometers and time in hours. After the second one, he's gone 170 kilometers. Correct, Mr. Moore?
Yes.
Next up, he's gone 340 kilometers. Then, no, sorry. Oh, right, I'm not doubling. I'm doing a mistake that everyone else in math class did. Right, so we're not doubling it. Here's a mistake that a couple of guys did. What they did was they doubled the first one and then they doubled the next one. And here I am solving it and I did the same thing. So we're adding 85 each time. So next up, Mr. Moore, we have?
255.
255. Human calculator behind me?
340.
340.
And 425.
And 425. Okay, so Mr. Meekin just made that common mistake that people were making on the test. I was doubling each time, but really what you're doing is if they averaged 85 kilometers an hour, it just means he's also traveling 85 kilometers each time. So it would be plus 85, plus 85, plus 85, plus 85. So each time he's traveling 85 kilometers. The next component of this is that you need to draw a graph. Now, whenever we're expressing something over time, we use a line graph. It shows progression over time. So I need two lines here, my x-axis and my y-axis. Okay, I have my x and I have my y. We start at 0. I'm going to have even increments for my scale increasing on the side of my graph. On my y-axis and my x-axis. Notice I used a ruler. I also want a title. My title down here will be time, brackets per hour. Then we're going to underline that, and over here we're going to say distance. And this is in brackets kilometers. Okay, your graph should also have a title. We're going to call this Josh's Drive to Cottage. Okay, so now we're going to fill in our values. We have 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. You always want to go one extra. And then on this side, we're going to have 85, 170, 255, 340, 425. Mr. Moore?
510.
Beat you to it. So after 1 hour, next up we're gonna plot. So we're plotting after 1 hour he's gone 85. After 2 hours he's gone 170, etc., etc. This is called a linear progression. It progresses in a straight line. When we do algebra later in the year, we'll look at linear equations. Now we're assuming that he's gonna continue that 85 kilometers if the drive were to take longer per average on my average speed. So my line could hypothetically just continue infinitely. Also, we wanna just make sure I'm gonna rush through this part and just use my pencil because I'm pretty good at drawing straight lines, but I'm expecting on a test that you're gonna do that with rulers. Finally, we need a therefore statement. Therefore, his cottage is 425 km away. Period. All right, we'll stop there for now, and we'll continue the final 4 questions in a part B video.